Good morning, class. Good morning, Lieutenant G. My name is Sebastian Chavez, and today I would like to present you all a subject that we saw for a moment during class, but I think it deserves a little bit of a deeper explanation. It's called the diving reflex, or the mammalian diving reflex, and in basic terms, the mammalian diving reflex gets triggered when our nostrils get wetter by cold water, being the more noticeable observation bradycardia or a slowing heart rate. But how is this achieved? Well, there are a couple of reactions in our body that make this possible. Starting by the carotid body, the main peripheral chemoreceptor, it responds to hypoxemia, which is a low oxygen, hypercapnia, which is a high CO2, and acidosis builds up in our bloodstream due to not exhalations that would discard the waste from our cells. Well, it triggers physiological responses to acute hypoxemia, such as when you hold your breath, and facilitates a ventilatory acclimation to chronic hypoxemia, such as when holding your breath gets prolonged. So in simple terms, it shunts blood away from our extremities to maintain body heat, and it distributes it to more important organs such as the brain and heart. But why do our bodies do all that for just getting our nostrils wetted? Well, all this indicates that our species has a common ancestor that used to use this reflex in order to thrive in the environment that it lived in. In fact, this reflex is not exclusive to humans. Nowadays, we find a variety of animals that, due to their style of life, this reflex is still seen in a more improved way, such as in the case of the anhinga, a bird that is found in Florida, and it's usually called a snake bird. It can dive up to 60 feet, and it can stay underwater for more than 1 minute, chasing its prey. But a minute or a little bit more does not really sound impressive when compared with the Spanish free typer, Hendrickson, that held his breath for 24 minutes and 3 seconds. Well, the key point in here is that Hendrickson achieved his record in a static apnea, that is motionless breath holding, while the anhinga holds its breath to fish underwater, making of course his oxygen consumption higher. But while the average person can hold its breath 30 seconds to 2 minutes, the anhinga could easily hold its breath that long if it had a more dominant brain like we have, that would allow it to think on a better way to prolong its time underwater by being able to block for a moment the brain signal for the need of oxygen, and use the little oxygen that is still left in the lungs, just like free divers do. But such a thing has come due to two main factors, which is inherent traits and something and another one that anhinga does not have, that is called social learning, which is the ability to pass information through generations, such as we do. Um, and yeah, of course, all this would not have been possible if our fish ancestors for millions of years ago, such as the Tiktaalik, Eusthenopteron, and Ichthyostega, wouldn't have taken the challenge of moving on solid land and taking on the challenge of breathing air. Uh,